cool.
So for my homework tonight, I got like most of it, and then there was just a few that I was like pretty shaky about. So I'll just give you one of those to start.
Okay.
The first one is tangent, parentheses, inverse sine, 1/3, and that's it.
Okay.
So I was just confused because these values, like 1/3, isn't on the table.
Can you use the calculator?
Hmm?
Are you allowed to use?
No.
No?
No.
Ah, interesting.
Yeah.
So we can't just plug it in. In other words, if you could use your calculator, you'd plug that in, come up with the angle. Remember that when you use inverse, you're always getting an angle as an answer. And then you take the tangent, and then you take the tangent of that angle. So this one, we're going to have to probably use the sine-cosine relationship. Gosh, I'm not sure I've ever done this.
Okay.
Let me think for a moment.
No, you're fine.
Is that the same thing as the question? I don't think so. I think I need it in the bottom also.
Yeah, I would guess. I don't know.
And then the sine of the inverse sine is just the argument. So that would be 1/3. But then I got this problem. I'm not sure how to handle that. Take me back to a similar looking problem that you did already and tell me how you did it.
Okay. Well, the one before it was cosine inverse, or inverse of cosine, parentheses, cosine of negative pi over 3.
Yeah, now see, that is just negative pi over 3.
And then you use table values.
Well, no, that's one of those you should know. Pi over 3 is 60 degrees. In other words, I can figure this out because pi over 3 is one of those common angles. We also know something else. We know the cosine of negative x is equal to the cosine of x, right?
Yeah.
Because it's an even function. Cosine is even, sine and tangent are odd. So the sine of negative x is equal to negative sine of x. So it's only cosine and its reciprocal that are even functions. And what that allows me to do is remove that negative sign, for starters. Okay. Now, when you have the inverse cosine of the cosine, there's your answer, pi over 3. In other words, 60 degrees. If they want it in radians, that's the answer, pi over 3.
But then don't you have to take the inverse of that?
Right, but when you have the same trig function, the inverse of the function is the argument.
Okay.
Okay. In other words, first of all, let's do this one at a time, just so you know exactly what I'm talking about here.
Okay.
That's minus 60 degrees. Fourth quadrant, cosine is positive, right?
Yeah.
So it's the same as the equivalent first quadrant answer, which is 1/2. The cosine of 60 degrees is 1/2. Whether it's fourth quadrant or first quadrant, doesn't matter. It's still 1/2. So
okay, that makes sense.
Now the problem becomes the inverse cosine of 1/2. And that is 60 degrees or pi over 3. So that's definitely the answer. Now, as to how you do these, in other words, most of the problems you've run into probably on your homework had the same trig function in both of those spots, right?
Yeah, most of them did.
Do you have one that you were able to do that has a different trig function?
Yes.
Good. Let's do that and show me how to do it, because I'm not sure I know how to do it. It'll probably be obvious once you show me an example, but what's the one?
Cosine, parentheses, inverse sine, negative square root of 3 over 2.
Well, now see, again, that's an angle that I know. That's 60 degrees. And it is the fourth quadrant angle. So it's actually minus 60 degrees. In other words, if I try to solve this problem by first solving this, always work from the inside out on these, well, you get minus pi over 3 or minus 60 degrees. Remember that sine is odd, so this would be the same as the negative of the sine of a pi. Well, yeah. You don't even need that information. You don't need to know if it's odd or even. What you need to know is that if you were going to draw that angle, this is the angle right here. It's pi over 3. In other words, the inverse sine of square root of 3 over 2, the reason I know that is from this triangle. This triangle should be the foundation of your trig, actually. There's 1, square root of 3, 2. Well, notice that the sine of 60 degrees is square root of 3 over 2. Yeah. So I don't need a calculator to answer this problem. In other words, this becomes minus 60, and then the cosine of minus 60, that's also in the fourth quadrant, so it's got to be positive. That's equal to 1/2. Again, 1/2 is the answer for this problem. Notice the difference in this problem up here. Without a calculator, I don't know what angle the sine is equal to 1 over 3. Yeah. I can draw the triangle. Oh, I guess that does. What am I thinking? Jeez, sorry. It just came. No, you're fine. I have no idea how to do it. So. No, well, now I realize it's easy as pi. Yeah. And the way you have to do it is draw the triangle, label theta, make that side 1, that side 3. Well, that makes this square root of 8, or 2 root 2, by the Pythagorean theorem. Now, I know what that angle is. That's theta. That's theta. So I have the triangle. What's the tangent of theta equal to?
1 over 2 root 2, and then you have to rationalize.
Which rationalizes to root 2 over 4. There's your answer.
Okay.
In other words, this problem is a lot like the following problem. That's why I can't believe I didn't see the solution right away. If I tell you that the sine of some angle equals 2/7. Without a calculator, I can't figure out the angle. But now if I say, what's the tangent of x equal to? Well, or any of the other 6 trig functions. And you might get a problem like this. This is a very common trig problem where they give you the ratio for one trig function, and then they ask you what are the other 6 trig functions. In other words, what's cosine of x, what's secant of x, what's cosecant of x, and what's cotan of x. Well, the way you always answer these questions is by drawing a right triangle and labeling x. And then label as much of the triangle as you can. Well, that has to be 2. That has to be 7. That makes this square root of 49 minus 4, square root of 45, which can be reduced, but I won't because it's not the final answer. Yeah, let's reduce it. That reduces to 3 root 5. And now I can figure out all 6 trig functions of x, right? What's cosine of x?
3 square root 5 over 7.
Yeah. What's tangent of x?
2 over 3 square root 5, and then you have to rationalize.
Correct. Remember this solution. And I say that with a smile on my face because clearly I did not.
Okay.
No, if I had remembered that this is the way you do all of these problems, then I would not have had any problem with the one you gave me.
Yeah.
Hold on a minute. I got to figure out this. Oh well, I won't worry about it. When I had 2 different trig functions, this is basically the same kind of problem.
Yeah.
In other words, they're telling you that the sine of some angle is equal to 1 over 3. That's what that means. It means there's some angle where the sine is equal to 1 over 3. So I can draw the triangle, make that my angle, and it's important when you do this to label which angle, because there's 2 possible angles you could be referring to, either acute angle, and now I can label this much of it, this much of it, now I can label this much of it. And now I can say what, you could put any trig function you want there and you're going to be able to answer this. So this really is very, very similar to what I just drew up there, where they give you 1 trig function and ask you the other 5. It's virtually the same problem.
Does it matter that it's inverse?
No. Understand what inverse means. If the sine of 30 degrees equals 1/2, we take trig functions of angles to get ratios, right? Well, this also means that the inverse sine of 1/2 is 30 degrees. We take inverse trig functions of ratios to get angles. So these two things mean the same thing. So the only difference, if I had that there and this was not inverse, but the sine of 1/3, well, they would have an angle there. In other words, they would have like pi over 3. Now, I know what the sine of pi over 3 is. That's square root of 3 over 2. And now I can figure out what the inverse tangent of square root of 3 over 2 is.
Okay. That makes sense, yeah.
Okay. So it's always you're either solving for a ratio or you're solving for an angle.
An angle, yeah.
Inverse is always solving for angles. And very practically speaking, I can give you one of the most famous right triangles you're very familiar with. But I bet you don't know what theta is.
Nope.
Because they never talk about it. They talk about the 3, 4, 5 as being the smallest perfect Pythagorean triangle, because 3 squared plus 4 squared equals 5 squared. But nobody cares what that angle is. But if you had to figure out that angle, what would it be as a trig function?
Would it be the inverse sine of 3 over 5?
Exactly.
Okay.
Or the inverse tan of 3 over 4. All of these are the same thing. Or the inverse cosine of 4 over 5. Notice that all 3 cases gives me theta.
Yeah.
And all 3 cases I'm taking inverse of a ratio to get an angle.
Okay, yeah.
Okay, and I find that extremely helpful. Now, you're liable to get confused when they start talking about radians and degrees, and they tell you that radians are a number.
Yeah, that is confusing.
Well, I can imagine. 30 degrees equals pi over 6 radians. But we don't actually use the unit here. We don't write radians. Well, guess what?
No.
That is a number. Pi is 3.14 and change, and divided by 6, you get a number. So radians being numbers is correct. They are. And when you get to calculus, they have to be in radians. Calculus, by the way, does not work with degrees.
Oh, that's good to know.
The first derivative of sine is cosine as long as the angle is in radians, but not if it's in degrees. So that's why they've introduced this concept of radians to you. But it's not quite like, I can say 1 gallon equals 4 liters, whatever the relationship is. And that's just a difference between the U.S. measuring system and the European measuring system.
Yeah.
Those things are equal. Degrees and radians aren't quite like that. And it's too complicated to even explain to you. I'm not sure I could even. It's one of those endearing mysteries of math that I wish I had an explanation as to how it's different than meters and feet.
Yeah.
Meters and feet are equivalencies if you have the right number of meters per feet. But degrees and radians aren't quite. You can certainly convert degrees to radians using a conversion factor, pi over 180 or 180 over pi. But the fact of the matter is they aren't really the same thing. And when you get to calculus, they're not the same thing at all. You have to do it in radians. All right, what else you have, Lauren?
Yeah, here's another one. It's pretty simple.
Now that I know how to do it, I'm not scared by it. It's amazing how when something is presented to you in just a slight different format, your mind doesn't recognize it as being the same problem as one that I do all the time.
Okay. Secant parentheses inverse tangent of 1/2.
So let's draw our triangle. Label theta.
Okay.
Now what other part of that triangle can I label?
The opposite side is 1.
This being theta. The inverse tangent of 1/2 being theta. In other words, eventually I want to figure out what theta is, and then I'm going to figure out secant of theta.
Okay.
Well, if I know the inverse tangent of theta is, if I know the inverse tangent of this ratio is equal to theta, then I can label that 1 and that 2. And then I can label the hypotenuse. What's the hypotenuse?
Square root of 5.
Now you can answer all 6 trig functions. What's the secant of theta?
Wait. It's opposite. So it's square root of 5 over 2.
I got the answer, and at no point in time did I have to figure out what theta was.
Okay, that makes sense.
Yeah, that's a key part of it. In other words, that's the reason they give you these, is you don't have to go into your calculator and figure out what the inverse tangent of 1/2 is to come up with an angle. That'd be one way of doing it, but they don't want you to use calculator exactly for that reason. They don't want you doing it that way. They want you doing it this way, which allows you to come up with the answer without solving for theta.
Okay.
That
makes sense.
Much in the same way as that other problem where, they tell you the sine is equal to 2/7, you don't ever solve for theta, yet you can still come up with cosine of theta and tangent of theta and secant of theta and all of them. So, all right, what else?
Okay. So I think I get those ones now. But then for like the second set or whatever of our homework, they got a little more complicated. Now they're like big expressions.
Okay. Give it to me.
Okay. Sine, parentheses, inverse sine of square root 3 over 2 plus, this is all in the same parentheses, sorry.
Okay, no problem.
Inverse cosine of 1, and that's it.
Okay. Well, that's theta, and that's alpha. So if I can figure out theta and alpha, I'm going to add them together and figure out what the sine of that angle is. Alpha plus theta.
Oh, so are you building two triangles?
I can, but I don't have to. I know these are the common answers for sines and cosines of common angles. By common, I mean multiples of 30, 45, 60, or 90.
Okay. Yeah, they're table values.
All of those. They want you to memorize the unit circle, right? The reason is so you know these.
Okay.
What's the inverse sine of square root of 3 over 2?
Is it 30 degrees?
60.
Oh, it's 60. Okay.
What's the inverse cosine of 1?
Isn't that 0?
Yep. So now the problem is, what is the sine of 60 degrees?
Okay.
Square root of 3 over 2.
2.
Okay. Now, before we go on, let me just address one other thing. When I say the inverse sine of 1/2, I'm talking about the first quadrant answer.
Yeah.
Because 150 degrees works also.
Yeah, it does.
The inverse sine of 150 of 1/2 is also equal to 150 degrees. If you take the sine of 150, you get 1/2. But if you put this into your calculator, it only gives you that answer. It's called the principal answer. And for positive, it's in the first quadrant. For negative, it's in the fourth quadrant. So if I said, what's the inverse sine of negative 1/2, the answer is technically minus 30 degrees. You wouldn't be wrong if you said 330 degrees. But actually, yeah, you might be. They're different. Yeah, they are different.
Yeah.
Minus 30 is this angle right here. 330 is this angle right there. But in terms of trig functions, they're all the same. In other words, sine of minus 30 is going to be the same as the sine of 330. Okay? But here's the thing that you have to memorize. The principal quadrants for inverse sine are 1 and 4. Same with inverse tangent. Let me list those. Inverse sine gives you either quadrant 1 or quadrant 4, depending on whether it's positive or negative.
Okay.
Same with inverse tangent. If I said, what's the inverse tangent of minus 1? Well, it's not 45 degrees, it's minus 45 degrees. Okay? Cosine is different. Cosine, positives go in quadrant 1, Negatives go in quadrant 2.
Okay.
So that's how inverse cosine differs from inverse sine. And here's what I mean by that. If I said, what's the cosine, the inverse cosine of 1/2, that's positive 60 degrees. But if I said, what's the inverse cosine of negative 1/2, it's not negative 60 degrees. It's whatever the second quadrant equivalent of 60 degrees is, which is 100.
120.
Yeah.
Okay.
So you always have to kind of pay attention to that. And this is the way your calculators work also. In other words, if you do inverse sine of a negative number, it gives you a negative angle in the fourth quadrant. It never gives you the third quadrant angle. Just like inverse tan of -1, well, not only is that minus 45 degrees, but it's also a second quadrant, 135. If I take the tangent of 135 degrees, I also get -1.
Okay.
But your calculator, if you take the inverse tangent of -1, it does not give you that as an answer. You have to know that that's a possible answer, but it's only giving you the principle. And the reason is that they want this to be a function, okay? Sine is a function, passes the vertical line test, no matter where you look at it. But once you turn it into an inverse, it's no longer going to be a function. That is not a function.
No.
So in order to make it a function, they restrict the domain, and they restrict it from first quadrant. This is the first quadrant right here. This is the fourth quadrant right there. So they restrict it between these 2 points. So that's why when you are graphing the inverse or the inverse trig, you only see a small piece of the continuous line. In other words, it looks something like I have a terrible time drawing these inverse. You know, it's the reflection about y equal x. So what does that look like? It's got to go through the origin. So something like that. Okay?
Yeah, that makes
sense. Notice that now I'm only looking at the first quadrant and the fourth quadrant.
Just reverse.
Yeah, so if you're taking the inverse sine of a positive number, you're in the first quadrant. If you take the inverse sine of a negative number, you're in the fourth quadrant. And it's still a function now. In other words, by restricting my domain, it remains a function. Well, what did they do with cosine? Cosine looks like this. Again, if I took the entire inverse, it wouldn't be a function. It wouldn't pass the vertical line test. So they restrict this between there and there. There's the first quadrant. There's the second quadrant.
Okay.
Okay? So that's how inverse cosine ends up being first and second quadrant. Inverse tangent or inverse sine ends up being first and fourth quadrant.
Fourth quadrant. Okay.
Okay, and that's always what your calculator gives you. And that can actually lead to some interesting problems like this one. Well, this gives you the fourth quadrant angle, which is negative.
Okay.
It becomes cosine of minus 30 degrees. That's the fourth quadrant answer to the inverse sine of -1/2. And now this actually becomes positive square root of 3/2 because I'm in the fourth quadrant.
Okay, that makes sense.
So you can frequently do these inside out if you know what these are without a calculator. But if you don't know what they are, you can still do it by drawing that triangle. Notice that the triangle I would have to draw, that would be 1, that would be 2, that would be theta, and this would be square root of 3. And now I can figure out what the cosine of that is, square root of 3 over 2. So I didn't actually have to know what the answer was. I just had to label the triangle and then figure out the other.
Okay.
Okay.
Can we maybe do one of those where we don't, like, the values aren't like table values?
Yes.
I have one if you want.
Good. Yeah. No, let's do it for sure.
Okay. Cosine parentheses inverse tangent of 4/3 plus inverse cosine of 5/13.
All right. Interesting. Huh. Very interesting. Well, this one I don't think we can, in other words, I could draw two triangles. First one, that's 4, that's 3, that's theta. So this is the theta angle. That necessarily has to be 5. Then if I draw a triangle over here, happens to also be a perfect Pythagorean triangle. And over here, this angle up here, which I will call alpha, that has to be 5, that has to be 13, that has to be 12. Now, without a calculator, or without solving for these angles, that's alpha, can I take the cosine of theta plus alpha? Wow.
So, wait.
Now I'm thinking here for a moment. What if we can turn this into cosine, inverse cosine?
How would you do that?
No, just so that we had nothing but cosines. In other words, I was thinking cosine of the inverse cosine plus the inverse cosine. We might be able to get somewhere taking that approach. Have you had sum and difference of sine and cosine yet?
Oh, yeah, we have done that, Ashley. That's probably how you solve it. Just kidding.
That definitely is how you solve it. Yeah. Okay, so what the sum is, so let's start up here in the upper left. I'll try to write small. So cosine of theta plus alpha, that's my problem, right?
Yep.
What's that equal to? What's the trig identity?
Isn't it cosine theta sine alpha?
Starts out cosine cosine.
Oh, those are sines, yeah.
Minus plus instead. It's opposite sign, and then it's sine theta sine of alpha. Okay? Now, using these two triangles, we know what each of these four things is. What's the cosine of theta?
3/5.
What's the cosine of alpha?
5/13.
What's the sine of theta?
4/5.
And what is the sine of alpha?
12/13.
There's your answer. Now, it's interesting. They don't want you to use a calculator, but you almost need a calculator to figure this answer. I guess not. What do we have? We have 15/65 minus 48/65 equal minus 33/65 without a calculator.
Without a calculator. Perfect.
Yeah. It was nice of them to make that 5 and 13, make both denominators 5 and 13.
Yeah.
So that we didn't need a calculator, you know, to come up with the final answer.
That makes sense. So you draw two triangles.
So we actually could have done that on the other one that you gave me, where it was the inverse cosine of 1.
Okay.
But since we know that, in other words, we don't know what the inverse tangent of 4/3 is. Without a calculator, I cannot solve for theta or alpha. And in fact, I never did solve for it, right?
No.
So we came up with the answer without solving for the angles. And usually that involves drawing a triangle or two.
Yeah. Okay.
But whenever you're looking at something like that, think sum and difference.
Sum and difference. Okay.
Because they've given you two angles in there. Remember, that's an angle and that's an angle. So it's basically the cosine of alpha plus beta, or whatever you want to call those angles.
Okay. Okay.
Okay. You have another one like that, I hope?
Yeah.
It's nice to do another one like that. Okay.
Okay. Sine parentheses inverse sine of 3/5 minus inverse cosine of -4/5.
Okay. What's the first thing we want to do here?
So it'd be the difference formula for sine, right?
Yeah, I would suggest you always start these problems out by labeling this. Let's call that alpha, let's call that beta.
Okay.
For two angles. So now we have the sine of alpha minus beta. What's the sum and difference?
It's sine of alpha cosine of beta minus cosine of alpha.
Okay, yeah, I like to keep them nice and patterned so I can remember them easier. In other words, remember what the cosine is. Cosine is cosine, cosine, sine, sine.
Yeah.
And opposite. And I think that's the reason they teach you the cosine one first. Didn't you find it a little strange that they gave you the cosine one first and then the sine?
Yeah.
Well, I think it's because it makes it easier to remember. In other words, the cosine of alpha plus or minus beta is cosine, cosine, minus or plus sine, sine. And, you know, this has to be alpha, that has to be beta, that has to be alpha, and that has to be beta. So if you can memorize that, which is relatively easy because it starts out with cosine, cosine, and then know that every answer has two sines and two cosines in it. And when you do the sine, the first term has one of each. Well, then you can't get it wrong. And so it makes it easier to memorize if you start out with the cosine. At least that's my
That makes sense.
That's my reasoning as to why they teach it like this. Is because this one's easier to memorize than this one. But once you've memorized this, you realize that there's two cosines there and two sines, and this has two sines and two cosines. So if you can get the first part, the second part falls into place. It's got to be just the reverse. The angles are reversed.
Okay.
Okay. So we know this is true. And now we have to figure out what the sine of theta is, what the cosine of beta is, and sine of beta and cosine of theta. Well, luckily on this one, we only need one triangle.
We do?
Yeah, because it's a 3, 4, 5 triangle.
Okay. Yep.
And the angle is, that's alpha and beta. In other words, there's our sine of 3/5 is this angle, alpha, inverse sine of 3/5, excuse me, and inverse cosine of minus 4/5 is same angle.
Yeah.
What's the sign? By sine, I mean, what's the plus or minus sign on alpha? Is it plus or minus?
Plus, right?
What's the plus or minus sign on beta?
I'm not sure about beta.
It is. It's the second quadrant. Remember, the cosine is the second quadrant angle. So alpha and beta are not exactly equal. If this one is 30, then beta is 150.
Oh, so cosine would be negative then.
Hold on.
No?
Well, I'm thinking a minute. It's the same angle, only it's in the second quadrant. But that means, well, let's just answer these 4 questions right here. So what's the sine of alpha?
3/5.
What's the cosine of beta?
4/5? Or negative 4/5?
It's negative 4/5. Minus the sine of beta.
Which is 3/5 also?
Correct, because second quadrant is still positive for sine. In other words, the sine of that angle, even though that angle is like 143 degrees, is the same as the sine of the 37-degree angle.
Okay.
It's still positive. It's a second, we know beta is a second quadrant. Let's write that, second quadrant. And this is first quadrant. So when we go to figure out what this angle is, no, we don't need these. We don't need that angle. I keep making that mistake. You don't need to solve for alpha or beta here. You just need to solve for these 4 things. You need the sine of alpha, the cosine of beta, the sine of beta, and the cosine of alpha. Now what's the cosine of alpha?
4/5?
Yeah, and it's positive because alpha is a...
Wait, why is that?
It's positive because it's a first quadrant angle. Now let me erase the triangle so I can write more here. In other words, alpha is first quadrant, beta is second quadrant. We know that from this information up here.
Yeah.
Okay, because cosine is negative. It's the inverse cosine of a negative number. That's the second quadrant angle. However, they're the same first. In other words, it looked like they were the same. Alpha is the same size as the reference angle of beta. You know what I mean by reference angle?
Yes.
In the unit circle, the reference angle is always the angle made with the x-axis. So even though I'm talking about a 150-degree angle, the reference angle is 30. And no matter which quadrant you're in, the reference angle is the equivalent first quadrant angle. So 150 is the equivalent of 30. And then you just have to figure out what plus or minus sign to put on it.
Okay. Yeah.
Okay? So here, I know the sine of alpha is a positive number, and I know the cosine of beta is a negative number, but I also know beta's second quadrant, and the sine of beta is a positive number. And beta's reference angle is the same as alpha, so the sine of beta also has to be 3/5, and the cosine of alpha is a first quadrant, it has to be positive 4/5. So my answer here is minus 12/25 minus 12/25, or minus 24/25.
Yep.
That
makes sense.
This one was a little trickier than the other one. The other one dealt with nothing but first quadrant angles, whereas this has a first quadrant and a second quadrant. Or if they'd have wanted, they could have put a fourth quadrant angle in there, you know, by making it inverse tangent of negative 4/5 or something.
Yeah. Okay.
Okay. Have any more of those? I wouldn't mind doing another one or two of those just to solidify our thinking. Those are...
Yeah. Okay, sine, parenthesis, inverse sine of negative 4/5 minus inverse tangent of 3/4.
Oh, I love it. Oh, no, these are also one triangle. It's the 3/4.
Oh, yeah.
It's the 3/5 triangle. And let's make it like this, though. Let's make this side 4 and this side 3. And this is going to be alpha. Okay? So notice that that's alpha, first quadrant. Inverse tangent of 3/4 is first quadrant. And it, oh, excuse me, I got the wrong one. This is alpha up here. Ooh, okay.
What?
Yeah, this is going to be a little different than the previous one, because it's the inverse tangent of 3/4. That's alpha, and this is actually beta. Excuse me.
Oh, yeah, I see that now. Okay.
That's going to be beta, and that's beta, only the fourth quadrant of beta.
Oh, yeah, I see that.
Okay.
The sine's negative.
Now, there is a relationship between alpha and beta. They're complementary to one another. Alpha equals 90 degrees minus beta, or beta equals 90 degrees minus alpha.
Okay.
So, let's see if that helps any. Let's see. Yeah, you know, if you try to figure out the problem from right here, it's very confusing. So always remember, the way to make the problem easier is to use the identity, and then you just have to fill in numbers and make sure you get the right plus or minus sign on it. Okay, so our problem is, what's the sine of beta minus alpha? What's the identity?
Is it sine of... Do you have to start with beta, or can you start with alpha?
I always start with the first one. And
okay.
Then the cosine is the other one.
Cosine alpha minus...
Yes, you do have to start with beta. because we're going to be subtracting. So it's going to be a different answer. If this first part is sine alpha cosine beta, I can't really start wherever I want when I'm doing the sign identity, because the fraction is going on, the order matters. When you're doing the cosine and addition is going on, you can mix them up if you want. But this one you can't. So the rest of it is sine, it's just the reverse.
Yeah, sine alpha
cosine of beta. And now we can figure out all of those. We have our alpha and our beta here. We just have to make sure we're in the right quadrant. And we know that beta is fourth and alpha is first.
Okay.
So what's the sine of beta?
4/5.
Positive or negative?
Positive.
Negative.
Wait, just kidding, negative.
It's 4/5, but we know it's in the fourth quadrant, so it has to be negative. Right. So that's why it's minus 4/5. What's the cosine of alpha?
4/5, but positive.
Correct, because it's first quadrant. Minus the sine of alpha?
Which would be 3/5.
Positive.
Mm-hmm.
Times the cosine of beta.
Which is 3/5, still positive.
Correct, because it's fourth quadrant, cosine's positive in the fourth quadrant. So that's all you have to do, is make sure when you draw your picture that it fits each of these. In other words, I think this is really helpful to label these two angles and then figure out which quadrants they're in. Because you really can't get to the final solution without doing that. And notice in this one, they weren't both the same angle. The last problem, they were both this angle here. Whereas this problem, one of them is that angle, the other one is the complementary one. And then this just becomes minus 16/25 minus 9/25. Look at how nice that is. Minus 45/25, negative 1.
Wait, how's that negative 1? Oh, just kidding.
Minus 16 minus 9 is minus 25.
Yeah, I accidentally added it and did negative 17. Oopsies.
So I believe every step here is required. I don't think I'd want to leave out a step. There may be a slightly similar or easier way to do all of this, but I don't think so. I think you have to draw the picture of the triangle, and you have to label the angles to fit this. In other words, beta is opposite over hypotenuse, so I got beta labeled correctly, and alpha is opposite, it's opposite over adjacent, so this has to be alpha. 3, 4. 3 over 4. And so we have two different angles in the same triangle, but at least that allows you to answer each of these 4 questions you have to answer down here. And as long as you know which quadrant they're in, you can answer them, but you have to know which quadrant they're in also. So this part's necessary. This part's necessary. I like this part here. I think it gives understanding. It also shows you immediately you have to use your sum and difference identity.
Okay.
And obviously you have to know that. And then you also have to know this. And you can figure this out from the way this shows up.
Yep.
And again, I never figured out beta. I never figured out alpha. The only thing I figured out was which quadrants they were in.
Okay. That makes sense.
All right, Lauren. You're always challenging. I love it. I get tired of the same old simple trig questions. So I like being challenged with these. These were challenging.
Yeah, these are.
Remember the drawing of the triangle. That is a key
Okay.
part to a lot of trig answers, is drawing a triangle.
Yeah.
And
Okay. That makes sense.
drawing the triangle, but labeling the angle you're talking about.
Like alpha or beta.
Well, or if I'm just doing a simpler problem and I'm up here and I want to get started, I got to label theta because theta could be that one or it could be that one. So if you don't label the thing, you don't really know where to begin.
Okay. Yeah, that makes sense.
If I'm doing a simpler problem that only involves one angle, I got to make sure I specify which one it is. And now I can say the sine is 4/5, so their 4 has to go there and the 5 has to go there, which means this is
3.
Okay. Now notice the tangent is equal to 3/4, so it's not the same angle. It's this one up here, x, for the tangent to be equal to 3/4.
Yep, that makes sense.
All right. We'll let you go. You have a good rest of your week and talk to you next.
Perfect. Thank you so much.
You're welcome, Lauren. Have a good one. Bye-bye.